resource person, Mr. Sabarinath Premlal, CEO, Respro Labs, Chennai, to August this gathering. Welcome, sir. It's indeed my great privilege to introduce our chief guest to this beloved gathering. Mr. Sabarinath Premlal completed his BE Electronics and Communication Engineering from Magna College of Engineering, ME Embedded System from Anna University, Chennai, and he has worked with multiple products, which includes embedded engineering graduate having a decade of experience in embedded hardware board design. He has served in several leadership positions for automation projects with several industries and institutions. He has also got a wide experience in costing and executing projects, inspections to launch, and is able to provide a structured framework to analyze complex situations into simple strategic imperatives. With his huge profile, it's indeed my honor to welcome you, sir. The stage is yours. Welcome, sir.
Yes, sir. Okay. Hi all, this is Sabarinath. Okay. Today I'll be going to explain you about what is image recognition, and also I'm connecting with the pattern recognition, and I'll be connecting with some use cases such a way that you can how we can able to start a startup somewhat like that. Okay, like entrepreneurship like that. So I'll be explaining. Okay, and in participant even previously I know Dr. Shankar. Okay, he is.
Hello.
Hi sir, how are you?
Hi, I'm fine. How are you?
Fine sir, fine sir. Okay. So he is great friend of me, and he knows very well about the way that I approach. Okay. So anyhow, now I'll share my screen. I'll kickstart it with a small demo. Then I'll connect with some advisable ideologies, connecting with some image recognition. Okay. So I think the screen is visible to everyone. Okay. So now I can able to start it. This is the genetic link that is available. So I'm connecting with the image processing first. So I can share this link to you all. Sorry. Yeah. So here, this is the space where I'm going to give the demo, and after the demo, I'll explain about the ML and DL in depth, and I'll update about some algo also, like CN and all these stuffs. Okay, and also I'll explain about the mathematical background about these things. So easily for you to recognize something. Okay. So here in this teachable machine, here it shows some class 1, class 2, like this steps. So in this class 1, class 2, so I am going to change the class 1, and I am going to take some real-time images. Okay. So I am having different development boards. Okay. I am going to take the images of these development boards, and I am going to present over here. Here, so I renamed as a MediaTek. So I'm going to take the image samples from the MediaTek processor. I mean the Linkit board. So I think I am visible to all. Okay, so this is the dev board. So I took around approximately around 100 images of this board. Okay. So again, I'm going to take with another sample, like I'm going to use the Renesas. So this is the development board. So I'm going to take the real-time images of this dev board. So I took around 100 images of this board also. So that board is, so I'll add at least 6 to 7 different boards. Based on that, how this image get recognized, and also we can work out with the Colab also. Okay, if you are having an environment, I'll update the Colab and I'll share the images. How we can able to do the calculation, all these steps we can able to start it. So now I'm going to connect the Azure board. So 100 plus images from the Azure board also. Then I'm going to connect the free scale. Fine. So I took 100 images and Arduino. So I took 100 different images also. And finally, I'm going to use the Raspberry Pi. So I took around 130 images. So totally I took 1, 2, 3, 4, 5, 6 classes. I took around the 600 to 650 images totally. So now I'm going to train the model. This happens everything in the cloud. So I'm training this model. It is getting trained actually. So practically it will take around maximum of 2 minutes delay. So that's what is happening now. Yeah, here this is the output. Okay, so 1 minute. So in this output, generally, if I'm showing my face, it recognizes me as a Raspberry Pi. Practically, it recognizes me as a Raspberry Pi. If I'm showing some other board like this, it recognizes as a Arduino with the maximum accuracy. And if I'm showing Azure, yeah, it recognizes as a Azure. Again, if I'm showing the Renesas board, it recognizes a Renesas. But as I'm showing the MediaTek also, it recognizes MediaTek. And if I'm showing like this, practically it identifies, even if I'm showing the MediaTek, practically it identifies like Raspberry Pi. The why this pattern happened. Okay, means in this data set I took the boards, but whereas in this data set only I took the samples of the images like like this. So here you can able to see I shown my faces. If my face is detected, this is recognized as a file. Okay, so like that this works. Okay, so it takes the image samples and it's working clearly, so nothing else. Okay, so like that this steps also is working clearly. So yeah, that's what I think you understood about these things. If I'm showing some other board, it recognizes. Even if I'm showing two different boards, it may get confused. Okay. So partially Azure and Freescale, you get confused, and partially it says Azure, partially it says Freescale. So what I'm trying to say is, okay, these things are all image recognition. This works clearly with CNN algo. Okay, based on this CNN algo only, this project works. Okay, even if you want to integrate in your app or app or website or whatever you feel comfortable. Okay, whatever the requirements might be, so you can able to export it by connecting like this. Okay, you can able to get the necessary scripts. Okay, then you need to do the necessary methodology such a way that you can able to integrate in your projects also. Okay, so these things are all highly possible. So that's what I'm showing here. Okay, so I think you got some clear understanding about how the image gets recognized. So this is purely a classification algorithm based on CNN. So I will explain those CNN and I will explain about those mathematical stuffs also. Okay, so I think you got some solution. Now I'll show some other samples with the audio processing. So now I've shown demo with the image. Again, I'll show demo with the audio. Then I'll export with the session. So you can also try these things whenever you are free. You feel free. It gives an clear understanding about what it is. Yeah, even I shared this link also. Yeah. So now I can able to connect with the teachable machine. So now I'm going to add some audio samples continuously for 20 seconds. Hi, 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 hi. Yeah. So I took these things. So I'm going to extract the corresponding samples. In class 2, I'm going to add another audio. Hello, 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 hello. Yeah. I'm going to extract this samples. Finally, I'm going to add one more class. How are you? 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 Yeah. So I'm going to extract this sample also. So again, the same procedure. Now I'm going to train the model. So So this is a concept of ML. So no need to program anything. That you should have the mathematical capability. You should do the programming of a base model. Okay. So after that only you can able to get the recognized output. Yeah. Here I can do hi, 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 hello, hello, hello. How are you? How are you? How are you? So this purely works based on the audio. So here I took only 3 different samples. So if I'm having some lakhs and lakhs of samples, then recognition might be better. So that it will shows a different fashion. Okay. So these things are all applicable with this demo. So you can also export this model also. Okay. So based on this model, you can able to recognize do the necessary steps such that you can able to incorporate into your projects. So I think you can able to do these steps. Okay. So now I think you got some idea. Now I just explain you about the actual session. So practically by basic, okay. So if you are having any requirement in ML or DL or whatever it may be, okay. So practically doing the image recognition is not a big task. That's the easiest one, okay. Because 90% of the code, not even 90, even I can able to say 100% of the code which is available in the market, in GitHub and everywhere. The one and only thing is we need to identify the particular place and we need to integrate it. So that's the logic. There only okay. So practically what we can able to do it means okay. If you are having an idea of how to kickstart and startup, okay. The one and only thing is you need to focus on how you can able to integrate the solution, how you can able to deploy the solution, because the most of the code is available in the market. Okay, no need to do the program in a different way or something like that. Okay, everything is available. Even if you are connecting any PhD or whatever it may be, if you are connecting with the GitHub, practically you will get the code, the advisable code, not the exact code. So around 90% of the code you can able to get it from the GitHub itself, and you need to do the slight modification. Then your objective will match. So everything is available in the market. The one and only thing is how we are going to integrate the solution to make the successful entrepreneurship or whatever. Okay. So now I've slightly given some basic intro about ML. Then I'll connect with the DL. I'm connecting with the neuron. So I'm giving an idea. Then I'll connect with any algorithm like the CNN or some other algorithm. Okay. So then I'll show some images. Okay, that itself will get you to around 12 o'clock. Okay. So ML. So by basic, what is ML means? It's a machine learning. So actually, what happens means the machine has to learn based on the data. Okay. Actually, what we are doing while we are riding the bicycle, okay, we need to concentrate on the right pedal, right leg pedal, and left leg pedal, right brake, left brake. Okay, okay, and then we need to concentrate about the hip rotation, the eye movement, everything at the same time. At the initial stage, we may get a bit difficult, but after the days goes, okay, we feel comfortable to ride the bicycle. Okay, so at the stage of learning, it's nothing but a machine learning. Okay, I'm not going to explain about VRL the machines like this. So this most of the people are knows that VRL the machines, our brain works based on the activities. So similar way we are connecting the machines such a way that the machines should understand. The machine should understand. Once it is understood, okay, then it automatically recognizes. Just now I shown some demo, okay, with the different dev boards. Okay, I added the data. Okay, I trained the machine. Once the machine is trained, the machine can able to recognize it. What the board it is, provided if it is having a camera. Okay, so this is purely based on the image processing. Okay, so this is happening based on the machine learning. Okay, so the thing is, if you are concentrating on machine learning, you need to focus more on how to work with the mathematical brain behind that model. Okay. So here, just like that, I can able to say automatically everything is processed. It's not like that. We need to focus more on the mathematical way. Even I can show you a link. Yeah. So here I'm just showing the starsmodel.org website. Okay. In this website, okay, if you are focusing on any statistical model, okay, you can use these websites. Okay, in this you can able to see the API reference. Okay. So in this, if you are focusing on regression, based on the data set, you can able to decide whether you can go to OLS or GLS with AR, covariance structure or whatever it may be. Okay. So ordinary least square, generalized least square, all these things you can able to work it out. Okay, so for imputation, for generalizing, and for different methodologies, so what might be the advisable algo? Okay, these things are all readily available in the website, in the statsmodel.org. So you need to connect this API if you are focusing on the basic statistical model. Okay, so what I'm trying to say is, okay, so you need to identify the necessary stats model thought process, then you can able to connect the corresponding stats model. Okay, so in this different algorithm is there. Okay, let's assume the first algorithm, OLS, ordinary least square. So if you are opening with ordinary least square, here the all the syntax, everything is given in the web. The one and only thing is we need to incorporate into our website, and we can able to identify the necessary changes, and that what we can able to get it. Okay, these things we can able to get it. Okay, so like this only we can able to add the different algos. Okay, so now so like this only we can able to do the process. So that's what I'm explaining about that machine learning. Okay, so then in machine learning there is a two different way. One is a supervised and another one is unsupervised. Most of you are all heard about these things. So let's assume supervised means the data points have known outcome. The data set, like if I'm getting a sample of a particular person's blood blood group, or let's assume I'm getting a particular person's blood details, okay, or diabetes details of the particular person. Okay, so then I can able to say whether he is having a diabetes under which category. So I can able to get these stuffs. But if I'm getting around 2 lakhs of people's data, okay, whether I can able to do it, the calculation, practically it's impossible. Okay, whether I'm having a diabetes or not. Okay, so in this case the supervised algo is advisable. If I'm taking a individual 1 or 2 samples, I can able to get it. But if I take the group of samples or large data set, it's hard to detect. So for those cases, we can able to connect with the supervised algorithm. For those cases, we can able to connect with the supervised algorithm. Okay. But whereas in unsupervised, this is a different case. Okay, unsupervised is a different case. Okay, we don't know how the outcome will be. Okay, practically, if I take some samples, I can able to predict the outcome in the supervised. Whereas in unsupervised, we can't predict the outcome. Okay, so that's a challenge. So we can able to do with the unsupervised methodologies. Okay, so both supervised and unsupervised. If you are focusing on stats, you can able to connect the stats model. If you are focusing on something else, you can able to connect the Skype also. And Keras, different tool. I mean, different webs are there. So based on that, we can able to connect with the necessary algorithm. Okay, it's up to the individual. It's up to the developer who can focus on which algo they can able to use or which category they can able to use. So it's up to the individual. Okay. So that's what in supervised algorithm regression classification, everything is there. So here, if you are in the position to understand this slide, I'm sure that you can able to understand the entire model in a different way. Okay. The thing is, okay, here the data with answers connected to the mathematical model. Okay. So here we need to program. So here we need to add the data set. Once we did this mathematical program, if we are integrating, then this is nothing but a training. Okay. After the training, it creates another model. Okay. Another model means this model is modified based on this data. Okay. This model is modified based on this data set. Okay. Now a new model is created. Now, if we are showing the data without answer, it can able to recognize and it can able to predict and give the answer, give the solution. Okay, this is highly possible. The thing is, here it shows the data with answers. Previously, I shown a demo, right? Okay, with image processing. Now there I connected the labeled data like Azure, Renesas, Freescale. These things are all labeled data connected to the model, that's pre-existing model. Now a new model is created after the fit, after the training, a new model is created. Okay, so now this model is capable to understand anything which is related to this data. So now I shown the data without answers connected to this model. It classified exactly and it predicted the predictive analysis based on this predictive analysis methodologies. So this clearly happened. Okay. Based on this only, it worked clearly. So I think you got some idea about what is that ML. The same thing we are incorporating in the DL and everything. Even this also I can able to show. These things are all labeled data connected to the model. And after that, I added the unlabeled data connected to the model. It predicts and it shows the solution. So this is also highly possible. So the thing is, what I'm trying to say is, okay. So these are all the basic ideology of what is ML, how this model works. Okay. So now I just connect with DL. Here I can show the neural network structure. So previously I gave an example that while we are riding the bicycle, okay, while we are learning how to ride the bicycle, initially we will learn and we do the necessary activities. Okay, we learn. Okay, so after that, after a certain days or certain duration, okay, around 1 month, after 1 month, suddenly if we are connected to a highway, practically if we are riding the bicycle in the highway, practically we need to follow at the left side, but we may do some mistakes. So that's a process. That's another form of an DL. Okay, what I'm trying to say is, if the same data is represented in a different way, so it has to recognize and it has to do the necessary process. So for that I can able to connect as a uh, 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 DL. Okay, so how this DL works, how the neural network is connected. Here practically we can able to see three different layers. One is a light blue, another one is orange, and third one is a dark blue. The light blue is an input layer, dark blue is an output layer. This orange color are all nothing but a hidden layer. Okay, so uh, how this hidden layer works? So that's the logic that I am going to connect. So mostly the ML, DL, everything is based on the human brain. Okay, so if we are in the position to understand or identify the human brain, we can able to get all this information easily. Okay. So I'm just going to connect the human brain now. Okay. So let's assume I'm going to give my hand to Dr. Shankar. Okay. So I can use him because he is my friend. He can understand me. Okay. So now I'm going to give my hand to him. Okay. So meanwhile, Professor Arun also is seeing the same scenario. Okay. So if I'm giving hand to him from the Arun perspective, okay, I'm giving hand to him. Okay. Within 30 seconds or 20 seconds, okay. Dr. Shankar also is giving hand to me. So from the Arun sir perspective, okay, he gave the hand. He responded the same. So from Arun sir perspective, its input layer is nothing but I gave my hand and he responded his hand to me. So he can able to view the input layer and output layer only. He can't able to view the hidden layer. It's impossible for him to view. Okay, but whereas from Professor Shankar's perspective, okay, if I gave the hand, he will see me. He will think whether I got affected with COVID or not. Okay, if he gets the info that I already affected with COVID, practically he won't give, or whether I looks dead or not, whether he knows me or not. Okay, so lots of logic will work in his brain. If all the logic will say yes, proceed, then only he is giving his hand to me. Otherwise, he won't give his hand to me. So that's the basic thing that happens by basing in our brain. So each and every logics or the mathematical calculation or everything we can able to say. So these things are all is nothing but a individual neuron. All the neuron says yes, you can proceed, then only he gives hand to me. Otherwise, he won't reply to me. Okay, so that's the logic which is worked in the professor's brain. Okay, then only he gives hand to me. If any logic says no, practically he won't give a hand to me. Practically he can't give. He won't give. Okay, so these are all the basic logic happening in the brain. Okay, so I think you got some idea about what I'm trying to say. Okay. So now I'm going to take a individual neuron. Okay, so I just explain about this neuron. So if I'm taking that neuron, okay, so these things are all input, which is from the previous layer, and this is the function. This is the output from the function, like the data from the previous layer and some transformation. Okay, so and the output after the transformation, the neuron output that transformed the data. So here I'm having a three different inputs. One is x1, another one is x2, and another one is x3. And the corresponding weightage for x1 is w1, w2, and w3. So finally the input is x1 w1 plus x2 w2 plus x3 w3. Okay, connected to the function. So if I'm connecting this, so I'm going to add some bias also. Bias means I'm going to add some error also, like B. Okay. So now the input is x1 w1 plus x2 w2 plus x3 w3 plus B. So this is the input which is given to the activation function. Okay. So that's nothing but z equal to x1 w1 plus x2 w2 plus x3 w3 plus B. Okay. So z is nothing but the total input. Output is f of z. After the function f, output is f of z. This is not a z transform. If the m is input, output is f of m. If x is input, output is f of x. So for that only I mentioned it as z. Okay. So it's not the case that this is nothing but a z transform. Okay. So I think you got it. Okay. So this is in the mathematical form. Okay, z equal to b plus summation I equal to m to m xaw. So these are all the basic things that we need to focus on neural network in the deep learning. Okay, I think you got some idea about what is deep learning it is. Now I'll show some, sorry, some algo like this. Yeah. So by basic, okay, I just explain you about that CNN algo. Okay. So CNN is nothing but a convolution neural network. Okay. So this works with the neural network, and this is a form in the deep learning. Okay, and it falls in the class of deep neural network, and this is most commonly applied to analyzing the visual imagery. Okay, even we can able to say this as nothing but a shift invariant or space invariant artificial neural network. Okay, so we can say SIANN. Okay, space invariant artificial neural network. Okay, based on the shared weightage architecture and translation invariance character. Practically, this can we can able to connect with the image and video recognition. Okay, so image classification, medical image analysis, neural language processing, brain computer interface. Okay, like this we can able to use. Okay, this is a regularized version of a multi-layer receptors. Even we can able to say fully connected network, that is each neuron is one layer is connected to all neuron to the next layer, and the fully connectedness of the network makes them prone to overfitting the data. Typically we can say the regulation including adding some form of a magnitude measurement of weightages to the last function. CNN takes a different approach towards the regularization also. So practically, this is inspired by the biological process in the connectivity pattern between the neuron resemblance and organization of the animal visual cortex also. So by basic individually we can able to say the pre-processing compared to other image classification can able to relate. This means that network can be filters that connecting with the different traditional algorithm. Okay, and this is a purely a scalar based one. ANN means that's a vector based one. Okay, this is the purely a scalar based one. Okay, so here that's what I'm going to explain it now. So by basic, if I'm saying about the kernel is nothing but a filter. Practically, the kernel is nothing but a filter. Okay. So how these filters works? So we'll be having some matrix format. Okay. Most of the images are all in the matrix format. Okay. How we are going to implement these things? So even I can able to show something like this. That's the same. I'm going to have a generic image. So I'm going to take sample of this image. Let's assume copy image. Listen, this is the image that I'm going to have. So by connecting, I think you might have used the shredder. Okay, so I'm cutting like this. Like this means I'm going to cut the images like this in a vertical position. So after please imagine it, what I'm trying to say. So here I'll cut the images in a different, around the n times. Okay. So this is the odd one, this is the even piece, again odd piece, even piece. If I take odd piece together and even piece together, the image me looks like this, like this. We can able to see two different images. Our images may looks like this. Again, if we do the horizontal cut instead of vertical cut, if I do the horizontal cut, okay, for multiple times, okay. So again, I'm for these images, again I can able to get images like. I'm just going to copy this. One minute, please. Yeah. So the images may come like this. So practically what I try to do it, this single images is segregated into 4 different ways. So to classify it, so everywhere it looks like the same. So actually I'm not doing the process with the actual cutting. So I did with the uh, image compression methodologies in a paint. In paint we can able to do like this only. Okay. So like this only it can able to hold. This is nothing but a 1:4 ratio, even 1:16 ratio, 1:8 ratio, different ratios we can able to do it. Okay. So here this how this CNN it will work. So based on that classification, okay. So it won't take. It will take this images itself. Okay. So if we are showing the images like this or some other big images or some other small images, it can able to recognize easily. So it particular pattern. I mean, not here. Yeah. So based on that only this works. So here I'm taking an sample images. If I'm connecting an image, everywhere all the pixel is having a mathematical value, a numerical value. It's not mathematical value, a numerical value. So here we are having an image called 3x3 image. Okay, in this 3x3 image, okay, each cell is having some number. Okay, this number represents the color. Okay, now I'm going to add a kernel. Okay, so I'm going to place this kernel over the input layer. Okay, if input layer is m cross m and the output layer is n cross n, the output layer will be m minus n plus 1. I mean 3 minus 3 plus 1 is nothing but 1. The output is only 1. Okay. So if I'm placing these things over the input and if I do the dot product and every individual, how it looks like. Yeah, I can show this. Yeah, like this. So 3 into minus 1, 2 into 0, 1 into 1, 1 into minus 2, 2 into 0, 3 into 1. So like this. So this how we can able to get that base calculation for output layer. So how it get compressed. Okay. So like this we can able to do these compression methodologies. So here if you are working with this kernel, okay, for CNN, okay, you need to focus on how the kernel will be. Okay, what the value of kernel. So if you are in the position to identify the kernel, so that's the research that you are making. Okay, now not only that, but that gives a big number output. Okay, so practically this subsampling and convolutions, again the subsampling will give a clarity of each and every output. So that's the logic that we can able to focus. Okay, so yeah, so that's what I can able to see. Okay, so here I can show with the different kernels. Okay, vertical line detector, horizontal line detector, corner detector. It's up to you to design. Okay, not only that you need to use this kernel. It's up to you to design. It's up to the developer. Okay, it's not the case that we need to focus these things. We need to focus that thing. So it's up to the developer. Okay. So based on the developer only, we can able to. The ideology of the developer, we can able to define what the kernel or what the filter it is. Okay. So then. Yeah, here I can show an image that this blue color is a kernel. This is the actual image. So actual image it comes as a 5x5. That blue color is nothing but 3x3. Okay. Practically, I can able to say if both are connected, this is nothing but a m minus n plus 1 will be the output. M is a 5, n is a 3. Okay. So 5 minus 3 plus 1 it's nothing but a 3x3, the output. Okay. So that's what we can able to say. That practically the kernel is nothing but a filter that is used to extract the features from the images. Even we can say the kernel is a matrix that moves over the input data and performs the dot product with the subregion of the input and gets the output as the matrix of the dot products. Even kernel moves on the input data by stride value. Where stride is 2, then kernel moves by 2 columns If the, I mean, it's based on the stride. Okay. So like this, you can able to connect. So even if you want to connect with any AI, you can able to connect these things. So, so by basic, if I'm connecting the kernel, okay, if I place this, I can able to get this value. But whereas I am considering this 3 cross 3 mid value, but I can't able to get the maximum utilization of this edge value. Okay. To do that, okay, by basic we will be doing like this only. Yeah. Without padding. Okay. If we are considering the edge value, even if I'm connecting the edge value, I can able to get the images of like this. So this is the maximum utilized one. Okay. So we can able to get a 3 plus 3. But whereas in this kernel, the one is not a central unit. Okay. So for this, we can able to do with padding methodologies. With padding methodologies like this, I can able to add one row at the top and one row at the bottom. Similarly, I can able to add one column at the right and one column at the left. So both the things are up, I can able to add it. Okay. So practically 2 rows and 2 columns are inserted like this. Okay. So if I'm can do it means, so I can able to do this edge also. So now totally this is nothing but a 1, 2, 3, 7 cross 7, 7 minus 3 plus 1. So practically the output will be 5 cross 5. Practically the output will be 5 cross 5. Okay. So 7 minus 3 plus 1 is output will be 5 plus 5. Like I can show some images like this. This is not an exact image, but I can give an ideology of how this looks like. So this is for the convolution process, and even I can able to do show with padding. So this is not an actual image. So I can give some idea of how it works. That's it. So this is how the CNN algo can work. Okay. So how the stride, that how you are focusing. So everything you need to focus. Okay. So this is how the normal image recognition, or it's not a pattern, it's a image. So if I'm connecting with the pattern, I can able to connect with the different use cases, and also I can show with the real-time use cases also. Today I will show with the pattern recognition post lunch. Okay. Now I'll be connecting you with so here I can able to give an clear ideology, okay, about how we can able to initiate and how we can able to do the necessary process, okay, for adding for to get the value from the images, all these stuffs I can able to get it. So here I'm having an image like this. Here I'm having an image like this. So practically what I'm trying to do, it means I'm going to get the value, crop this value only. Crop this value. This is the image. How to, to identify the blood clot inside the brain. This is to identify the blood clot inside the brain. Okay. So totally, in this, once I discussed with the doctor, here the slicing position will be from 0 to 120 degree. Okay. So for 120 degree, we can able to get the different slicing position. Okay. So and in this 120 degree, okay. So here I am showing with the slicing position of 77.4. Okay. If some position it may give, here it gives some white color pattern. Okay. So in some of this pattern. Okay. The thing is, what he said is means, so totally for 120 degree means for each and every degree 10 divisions are there. So 120 point, 100.2. So 120 into 10. So totally we can able to say it's around 1200 different position is there. And plus 75 position, 75 logics. Okay. So that I will explain it. Okay. So total 1275 solution, 1275 positions are there. In this 1275 positions, I'll be calculating with each and every position. Okay, we need to have the images of at least 20-30 different positions. Then only we can able to recognize whether he got affected with blood clot or not. Okay. So I'm not good in biology. Please don't ask anything in biology. Okay. So if you are having a doubt in technical way, so I can explain it. So here, so this is the necessary. Previously I said, right? All the codes are all available in the market. The one and only thing is how you are going to integrate that solution to get the exact match. Okay. So here I am going to importing that necessary packages for matplotlib, numpy, pill. Okay. So so I am importing the necessary packages. I added the images also. Now I am not doing, so I am just showing. Okay. So here I added the images. The total pixel is 768 cross 1024. Okay. So I am connecting the images. Okay. So I am going to convert these images into the normal value. Practically that itself in the normal value only. So here, once I got this data, so I'm going to get the each and individual data over here. Okay, how I'm going to connect it, how I'm going to convert it. So all these things I'm getting. So here, img equal to image.open. So once I open, so I'm loading all the value to the raw data. Okay, so here is a view and I can able to show better. I will run it. So it will take the first time it will take a bit delay based on yeah. The images. So if I'm printing the normal raw data, it's a different case. it has some objects. So if I'm printing the raw data of, let's assume 7 6. We'll get a value. Okay, so this logics works with this matrix. So now our matrix size is 768 cross 1024. 768 rows and 1024 columns. Okay, so here I'll be getting these images. Okay, and I'll do the necessary process. So the thing is, what I'm trying to show is, if in this question, okay, so this is already in the grayscale. So I'm just ignoring this field. This is already in the grayscale. 1 minute, please. So I just close the door. Next to my home, there is a construction work is there. Please, 1 minute. Yeah. So if the 77.4 slice is, slice position is there. So practically this image, by connecting this, so this image starts from 300, okay, in a row wise, ends at a 580, okay. Again in column, it's start from 350 and it ends at a 650, okay. So if I'm cropping this particular space, I can able to get the actual image. I can able to get the actual image. Even I can able to ignore the rest of the fields, okay, by connecting this. So once I started to do this process, okay, here everywhere we can able to see the white color, but whereas this white color is entirely different from this white color, normal white color. So for this white color we will be having a different value, for other white color we will be having some other value. By connecting these things, okay, I can able to get the change in the value, okay, like yeah, somewhat it raised to 240 or something else, okay. Sorry, so 240 or something else. So for those cases, I can able to recognize here this pattern is having some sort of an value change. So if it is greater than 200, there is some impact. So we can able to identify based on that matrix value, and we can able to define, okay, so totally we can able to identify, I just copy this and I can do it with a pen. Our understanding value will be, thought process will be a bit different. Let's assume I am going to do the calculation here only. Like this. I'm going to do the calculation here only. Now I can able to segregate into two different way. Okay, one is a left brain, another one is a right brain. Okay, even I can able to segregate left brain, layer 1, layer 2, layer 3, layer 4, I can able to get. So I can able to get the average value. Okay, so mostly this will be around 100, the value at this space. I mean, sorry. So the value at this space, it will be 100. Okay, it will be 100. Where its value at this space will be 200.